Assalamu'alaikum warahmatullahi wabarakatuh. Good morning everyone. The Honorable Miss Silmi Hadizatul Humaida as the lecturer of English course. Let me introduce myself. My name is Nabila Zulfa Rahmawati, a student of Mathematics Education, Faculty of Teacher Training and Education at the University of Jember. After this short introduction, I would like to start explaining my material, which is vectors. I hope everyone can enjoy and understand the explanation.
Anyway, in this session, I will explain the definition, representation, magnitude, and some operations of vector. First of all, let's start with the definition of a vector. A vector is an object that has both a magnitude and a direction. Geometrically, we can picture a vector as a directed line segment, whose length is the magnitude of the vector, and with an arrow indicating the direction. The direction of the vector is from its tail to its head. Now that we know the definition, we can move on to the representation of vector. Vectors are usually represented in bold lowercase or using arrows. We denoted that the magnitude of a vector A by absolute value of A. The standard form of representation of a vector is A equals A times I plus B times J plus C times K. Here, A, B, and C are real number, and I, J, and K are the unit vectors along the x-axis, y-axis, and z-axis respectively. Next, let's discuss the magnitude of a vector, which tells us how long or how big the vector is. The magnitude of the vector can be calculated by taking the square root of the sum of the squares of its components. In here, if A, B, and C are the components of vector A, then the magnitude formula of A is given by square root of A squared plus B squared plus C squared. The next part is about vector operations, such as addition, subtraction, and scalar multiplication. For the first operation is addition. There are two laws of vector addition. The first one is triangle law. The law states that if two sides of triangle represent the two vectors acting simultaneously on a body in the same order, then the right side of the triangle represents the resultant vector. The second one is parallelogram law. The law states that if two co-initial vectors acting simultaneously are represented by the two adjacent sides of a parallelogram, then the diagonal of a parallelogram represents the sum of the two vectors, that is, the resultant vector starting from the same initial point. The second operation is subtraction. The subtraction of a vector is similar to addition of vectors, but here only the sign of one of the vectors is changed in direction and added to the other vectors. The last operation is scalar multiplication. A scalar is a real number that has no direction. When a scalar is multiplied by a vector, we multiply the scalar by each component of a vector. The operation of multiplying a vector by a scalar is called scalar multiplication. So, when vector A equals A1, A2, and A3 is multiplied by a scalar R, the resultant vector is R times A equals R times A1, R times A2, and R times A3. Finally, we come to the conclusion, where I will summarize the key points about vectors. From this presentation, we have learned the definitions of a vector as an object that has both a magnitude and a direction. Its representation both graphically and algebraically, the formula to calculate its magnitude, and several operations including addition, subtraction, and scalar multiplication.
Two real-life examples of vector are used that represent force and velocity. Both force and velocity are in a particular direction. The magnitude of the vector will indicate the strength of the force or the speed associated with the velocity. So, vectors are important because they help us describe quantities that involve both size and direction in mathematics and real life. So that is all for my presentation today. Thank you very much for your kind attention. Wassalamu'alaikum warahmatullahi wabarakatuh.